Okay, in our second example of pressure versus temperature, again, let me remind you one last time that pressure and temperature are directly proportional, meaning as one goes up, the other goes up. So we're going to again be using the formula P1 over P2 equals T1 over T2. Okay? So let's read through the problem. Alex is given a helium-filled balloon when he goes to Chuck E. Cheese's. When he goes outside, he starts crying because the balloon shrinks. Why? There's a lot of gas laws involved here. If the balloon started at a pressure of 1 atmosphere and 20 degrees Celsius, and the temperature outside is 5 degrees Celsius, whoa, that is a cold day. Because think about it, 0 degrees Celsius is the freezing point of water. So it's just barely above freezing. And the temperature outside is 5 degrees Celsius. What is the pressure in the balloon, ignoring changes in volume? Obviously, we're talking about a elastic balloon, which is why we have to ignore the volume. Okay, in the previous one, it was in a metal canister. Obviously, the metal canister is not changing volume. So let's look at what we know. We have a pressure of 1 and a temperature of 20 degrees Celsius, which is about room temperature. So our P1 is equal to 1.0 atms. Our P2 is what we're solving for because it says what is the pressure. Our T1 is 20 degrees Celsius, but again, we do not leave it as Celsius. We have to add 273. Why? Because when you convert to kelvins, kelvins is degrees Celsius plus 273. It's a constant. It's always 273. Now we do our T2. Our T2 is only 5. So we've got 5 degrees Celsius plus 273, which is equal to 278 Kelvin. Now, plug into the formula everything we just wrote down. 1.0 atm, our P2, 293, and 278. Before I pull out my handy dandy calculator and calculate myself some P2s, should my answer go up or go down? Okay, so think about it for a second. That was 1 second. Okay, now obviously you can always pause the video whenever I tell you to think about things. So let's think about this for a second. What happened to our temperature? Well, our temperature dropped. If our temperature goes down and pressure and temperature are directly proportional, that means our pressure had better go down. So let's make sure that our pressure is less than 1 atmosphere when we're finished. Let's pull out the calculator. So I take my P1, 1.0. I multiply it by my T2, which is 278. And I get 278. Wow, that's a shocker. Okay, now I divide it by the thing that's going to be multiplied by my P2, which is my 293. And divide it by 293. Hit enter, and I get 0.949. Okay, so I get 0.949 atms. Why? Because I always tell you we want 3 digits, starting with the first non-zero. That 9 is the first non-zero, so the 949 is what stays. Now, does my answer make sense? Absolutely. As we just said before, the temperature goes down, the pressure had better go down. Our pressure went down. I know immediately that my answer does actually make sense. And that's how you solve pressure versus temperature examples.